Example 3 has the same structure. We have a cube root of 3 times the 4th root of 3. Be careful, they don't always put the dots there. If this root is over top of this at all, so you got this guy here happening, if it's anywhere over top of that, it's attached to the radical. If it was written like this, see, it's not written, so it's kind of over here. Now it's attached to the 3. So just make a clarification there. I always put this raised dot in my presentation, but it doesn't do that in the book. All right, so if that number's over top of that radical whatsoever, it is part of the radical. So looking at the structure again, we have a radical inside a radical, so it's the same kind of problem the last one was. We have a number 3, which is to the first power, and we have a number 4th root of 3. 3 is to the first power, and this time it has a 4th root, and we're doing a cube root of the whole thing. So if I take a look at the whole thing, I've got a cube root. Okay. And be careful that little 3 is up there in the nook. It doesn't become, I've seen people see this structure, so they think that's how the answer is supposed to be written. That little 3 is in the little nook there. It's a cube root. This is 3 times the square root, so they mean different things. So be careful of that. Just writing good, proper mathematical structure here. This 3 is to the first power. All I'm going to do is bring that down. The whole number inside the radical just comes along for a ride. It's got a power of 1 officially on it. I do always write that power of 1 just to remind myself it's there. And then I'm going to be multiplying this times another 3, which is being raised to the 4th power. So again, that's priority 1. Create a fractional power structure inside the radical. So my main radical is here, 3 to a power times 3 to a power. That allows me to use my x to the m times x to the n rule, this rule up here. I'm going to be able to add the powers together. So next step, still have a cube root, because again I don't deal with this till the very end. And I need to create a single object here, 3 to a power. And again, the rule tells me I'm simply add the powers. So if I add 1 plus 1/4, what do I get?
5/4.
5/4. 1 is 4/4 plus 1/4 makes a total of 5/4. So what I have circled here in blue is the equivalent to 3 to the 5/4 power. And finally, once I get a radical of a fractional power, I'm going to multiply the root times the denominator. Nothing happens to the 5 or the 3. So 3 stays 3, 5 stays 5, 4 and 3 multiply to make 12. 5/12 doesn't reduce. Fraction reduces, you should reduce it. That's worth doing. But 3 to the 5/12 power is equivalent to that. And here's verification of that fact. And it's a little harder to type this one in. In your math menu, there's a 4th root button, or a 3rd root button, and an xth root. That'd be the 4th root. We got to put the root in first. So the way I type it in, cube root, parentheses. And then I got 3 times the 4th root. And the way you type in a 4th root is you have to type 4 xth root. That means 4th root. Parentheses 3 end parentheses. Here's the 4th root of 3 times 3 end parentheses for the whole radical. That's what that is. And if I do 3 to the 5/12, oops. Might help if I hit the 5 divided by 12. 3 caret 5 divided by 12. 1.5805, 21918, same thing. All right. That's a little bit tougher to type in, so maybe just have belief in yourself. Maybe it might be good. Or maybe you're messing up a bit from here to here. You want to make sure these are the same thing. 3 times 3 to the 1/4. And then 3 to the 5/4. Just be careful that when you're typing into a fractional power that you put caret parentheses, fraction in parentheses. Make sure it's that. If you type in 3 caret 5/4, your calculator thinks it's 3 to the 5th, which is 243, then divides that by 4, which is different than taking 3 to the 5/4 power. So again, knowing how your calculator thinks is important. Fraction powers and parentheses around the power is necessary. All right, so that's it. Again, you notice the structure, you know what the answer is supposed to look like, you go through the process to make it look like that, practice the skill, get good at it, and again, within a few lessons we're going to start throwing some different numbers here. These will be different to start off with, we'll have to make them the same, and then that's as hard as they're going to get for this year.